This is the second lesson in Module 3, and we are going to be solving some one-variable quadratic equations. So a little bit of review of stuff we looked at from before, with some word problems thrown in too. All right, so example 1 here, we are asked to, or we're told here that a physics teacher put a ball at the top of a ramp and let it roll down toward the floor. The class determined that the height of the ball could be represented by the equation h equals negative 16 t squared plus 4, where the height h is measured in feet from the ground and time t in seconds. Okay, so the h is height in feet from the ground, t is time in seconds. What do you notice about the structure of the quadratic expression in this problem? How can this structure help us when we apply this equation? So, looking at the quadratic equation here, what do you notice about this? Well, there's no t term, right? It's missing that linear term t. So in other words, we could write it this way. It doesn't have a t term, 0t, okay? Which means then, since we only have this single t right here that we're solving for, we don't need to use factoring, for example. We'll be able to just isolate and solve using square roots. So we'll write that. We can solve using square roots. Because there is only one t variable. Okay, so let's continue on. Letter B asks, in the equation, explain what the 4 represents. So that 4, all right, so right now the equation is h equals negative 16 t squared plus 4, okay? We can get that 4 by itself by putting in what number for t? So what number can we put in for t that will kind of like eliminate everything else and just get this 4 by itself? Well, the answer is 0, right? So we put 0 in for t. Okay, 0 squared is going to be 0. 0 times negative 16 is 0, so we're left with just h equals 4. So what does it represent? Well, what does a time of 0 represent? If the time of something is 0, that means it's at the start, right? And then this h, what does h represent again? H is measured in feet, and it's the height, okay? So this represents that the height of the ball at the start is 4 feet. Okay? Start because, remember, it was t equals 0. Explain how you would fill the equation, explain how you'd use the equation to determine the time it takes the ball to reach the floor. So now, reaching the floor. What do we know about the ball when it's reached the floor? Do we know how long it takes to reach the floor? Well, that's what we're trying to find. Determine the time it takes. Means we're going to be solving for t. So t equals what, right? Reaching the floor, though. So what would reaching the floor? What would the height of the ball be if it hits the floor? The height of the ball would be 0, right? So we want to know what is t when h is 0. So we'll put 0 in for h and solve for this t right here. And we'll do that by subtracting 4 on both sides. We get negative 4 equals negative 16 t squared. And then we will divide both sides. So we'll get negative 4 over negative 16 equals t squared, or t squared equals 1 over 4. Square root both sides. And get t equals 1 over 4. Actually, it should be plus or minus 1/2. Sorry, the square root of 1/4 is 1/2. Now, consider the two solutions for t, letter D says. Which one is reasonable? So you tell me, think about it. Which one of these answers is reasonable? Positive 1/2? Negative 1/2? Does the final answer make sense based on this context? So, which one's reasonable? Okay, the answer is t equals 1/2 seconds is reasonable. because this means the ball reaches the floor after half a second. What would not make sense is to have a negative 1/2, because that'd be going backwards in time, and that wouldn't make sense in the context of the problem. Okay? In the next video, we will take a look at example 2.